Okay, Assalamualaikum warahmatullahi wabarakatuh, and very good afternoon to Dr. Ashadi, our lecturer for BE 2254 Electronic Systems. So today we will present about our project for this subject. So first of all, I will introduce my group members, which is first Muhammad HAKIMI bin HALIM, JEEVAA anak lelaki Prakash, Muhammad BASIR bin BAKAR, Muhammad SHAHEER bin Muhammad ZAID, Muhammad AIMAN bin Muhammad ZULKERNAINI, Muhammad MUADDIB BAKHTIAR bin MUZAFAR, Muhammad ASHRAF bin Muhammad AZMAN, NICOLAS anak lelaki Joseph, dan me, Muhammad Amar Fadlan bin AHMAD FOZI. So for the next explanation, I will pass to my friend.
Hi, Assalamualaikum. My name is Muhammad BAKHTIAR, and I'm going to explain about my role in the electronic system project, that is construct a circuit for oscillator 1. So I'm going to explain about oscillator 1. Okay, before I explain about the circuit here, we have to understand the function of the oscillator circuit. So the function of electronic oscillator circuit is the circuit will convert direct current or DC from a power supply to alternating current or AC. The oscillator have been used in many electronic devices. Alright, we can see it almost in every electronic device. Alright, and then let's go to the component that I have been used in this circuit. Okay, in this circuit I use 741 op-amp. I use capacitor, resistor. That's all. Okay, for the resistor I use 215 kilo ohm resistor for R1 and R2, and for R3 I use 100k ohm resistor, and for R4 I use 47k. And for capacitor, most of the capacitor that I have been used is 0.01 microfarad. Okay, if you can see here in this what we can call lab sheet for this project is, for oscillator circuit, it want me to construct a wind bridge oscillator circuit. Okay, this is a oscillator circuit, and then it want a resonance frequency that go to 1 kilohertz, and the DC supply must be 15 volt. So I have used the VCC for 15 volt. And before I construct the circuit, I have go through some calculation that my friend will explain to you later. Alright, and I have got 1 kilohertz. After doing some calculation, that's why I use this spec or this specification for resistor and capacitor. So I will show you that I got the resonant frequency for 1 kilohertz. So let's see. As we can see here, the frequency is 1.04 kilohertz. So it match the spec that I've been required. So this is my circuit. So I think that's all from me. I'm gonna pass to my friend. Thank you. Kamalan.
Assalamualaikum. My name Muhammad Basir bin Bakar. Today I will explain about oscillator 2. Oscillator type wind bridge oscillator. The value given is resonant frequency 20 kHz, DC supply VCC plus minus 15 volt. As you know, the wind bridge oscillator use a feedback circuit. So series RC circuit connected with a parallel RC of the same component value. So it produces a phase delay or phase advance circuit depend the frequency. In particular, one arm has resistor and capacitor connected in series, as you can see R2 and C2, while the other has them in parallel, C1 and R1. This indicates that these two arms of the network behave identical to that of high pass filter or low pass filter. As you can see, C2 and R2 is high pass filter, C1 and R1 is low pass filter. In this circuit, at high frequency, the reactance of the capacitor C1 and C2 will be much less, due to which the voltage will become zero as R1 will be shorted. So, at low frequency, the reactance of the capacitor C1 and C2 will become very high. At this circuit, the value at R1 is equal to R2, C1 is equal to C2. So the value at R1 is 10 kilo ohm and the value at C1 is 550 picofarad. We assume the value at R3 is 10 kilo ohm. So the value at RF is 2 times at the value at R3. So the output we get is almost 20 kHz, has the same value at resonant frequency given. That's all from me. Thank you.
Assalamualaikum and good afternoon. So this is my project ES that I have done. So for my part is I doing is active low pass filter. Okay, this is the most common and easily understood active filter is the active low pass filter. So it's a principle of operation and frequency response is exactly the same as those previously seen passive filter. So the only difference this time that is used and copy application for application and gain control. So the simplest form of a low pass filter is to connect an inventing or non-inverting amplifier. So this is the measurement that I got from this him. And then so this is for the block filter. I got 8 kilohertz. Okay, this is for my discussion where frequency cut-off given, which is 8 kilohertz. So we need to determine the value of resistor and capacitor. And Values for approximate butterworth response used in the circuit second order active low pass filter consists of 1 OP and 2 post the first stage, where the 2 resistors and 2 capacitors and non-inhibitor filter gain. As we can see in its also the voltage output is 1.5 V and voltage is 9 amp in the both plot. We can see the cursor right at the cursor off and the Y1 value which is gain in dB for 4.2501. Below are the comparison between experiment result and calculation. So this is experiment. So this is for gain in dB. This is my calculation. So since R1 and R2 1.8 simplicity and symmetrical value capacity C1 and 2, as I calculate, we got 11.05 nanofarad. This for butterworth response in the first stage, I got R3 for 1.055 kilo ohm. And this is for my gain of this low pass filter as defined as a AF 20 log 4.06 dB. And then as conclusion, by refer the butterworth response table, we can understand how design the proper circuit of low pass filter or any such as high pass or band pass. So the low pass filter is kind of filter that is used to allow frequency below the cut or critical frequency to pass and reject others. So that's it for my part. Thank you.
Okay, so I am Amar Fadlan. So what is a rectifier? Rectifier basically is a device that converts an oscillating two-directional AC into a single directional DC. So rectifier here can take a wide variety of physical form, from vacuum tube, diodes, and crystal radio receivers to modern silicon-based design. So there are a few functions of rectifier. Rectifier are fundamental to how many different devices operate because the standard electrical distribution grid uses AC power. Any device that runs on DC power will require a rectifier to function correctly. So virtually all modern electronics need the steady constant power of DC to operate correctly. So basically rectifier function are to convert AC to DC. So for this project, I have done my part, which is rectifier circuit. Okay, so as we know, yeah, the bridge I have done it manually. Just put the diode here, 4 diode, and connect to be like a bridge. So we need to put a capacitor here in order to act as a filter. So filter here will act as will filter the sine wave to make it more near to DC wave. So as we can see in the oscilloscope, the sine wave should be half without the capacitor, but after we add the capacitor at the end of the circuit, then the form of the wave will ripple. So here the type of the example of ripple voltage. So it is nearly uh, uh, to convert to the DC direct current, direct linear waveform. So that's all from me. Thank you.
Fellow lecturer and to my fellow teammates, I'm JEEVAA PRAKASH from 2BEE, section 1/2, and I'm here to present about my part, which is voltage regulator. And this is one of the circuit that my teammates helped me to do, helped me to conduct a circuit about a voltage regulator. And I have used a shunt voltage regulator for this current circuit. A shunt voltage regulator usually works by providing a path from a supply voltage to the ground through a variable resistance. The current through a shunt voltage has driven away from the load and flows uselessly to the ground, making this from usually less efficient than the series regulator. And for the shunt voltage regulator, this is the circuit that I did, and it is only suitable to relatively small current and fixed range of voltages. There is a number of limitations for this circuit also, and the diodes that are used for this is a Zener diode, which is 1N4731. Okay, and the transistor I used for this is a 2N22222A. And for this, the Zener controls the transistor of the shunt voltage regulator. And here, here its ungrateful voltage is directed proportional to the voltage drops occur in the series resistance, and this voltage drop is related to the current is given to the load. The output voltage is related to the transistor base emitter voltage, which is VBE, and a Zener diode. The most common method is using for this basic Zener diode shunt regulator is the point of load regulation system. This method is uses a number of fixed voltage, and for this current diode I have used a 10 volt. It is apart from the main circuit. So for myself, for conducting this, I have did a 10 volt, and we have used for the main circuit it is 13.8. And for this, the reality inefficient main regulator can then be used in the power supply unit, because each section of the circuit has its own regulators. And for this, I would like to run and show you about voltage, and it is 5.016 volt for output. And if I change the volt to 13.8, it still comes out with a voltage of 5.1, which is plus minus for the shunt voltage regulator. And thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AIMAN bin Muhammad ZULKERNAINI. My matrix number is B0819101799. So today I want to present for my part in electronic system project. So for my part is to combine all of the circuit to be one circuit. So actually we have 5 circuit that my friend have do. So first circuit is oscillator 1, oscillator 2, low pass filter circuit, rectifier, and basic shunt voltage regulator circuit. Okay. From five circuit, my friend have measure the output voltage for each circuit. So they will explain about their own circuit for the output. So today I want to present about only for this circuit, what will happen at every circuit and what we get at the end for this circuit. So firstly, at oscillator 1 as oscillator 2, it will we get 2 output. So at the summing voltage, it will change to 1 output. So from the 1 output at the summing voltage, it will go to the low pass filter, and at the low pass filter it will change the frequency to the low frequency, and from the low pass filter it will go to rectifier, and at the rectifier what will happen at the rectifier, So from the AC voltage, we will change to the DC voltage at the rectifier. So and then we get the DC voltage and it will go to the basic shunt regulator circuit. Okay, what will happen at basic shunt regulator circuit, we will get the smooth power. So and then we will get the output. So the output we get from this all combination circuit we get is 7.991 milliwatt for the last output for this circuit. So that's all from us. I will pass to the next presenter to present their part. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad bin Muhammad ZAID. Today I want to explain about the simulation and result. For the first simulation result is oscillator 1. The oscillator type is when bridge oscillator. The general frequency is 1 kHz. DC supply we using the plus minus 50 volt. This is the oscillator 1 circuit. So we're using the 7.1 amp. After that we get this output and the oscilloscope. So we move to the calculation for the oscillator 1. So this is the general frequency 1 kHz. DC supply plus minus 50 volt. So the resistor is 50 kilo ohm. R1 equal R2. So the capacitor is 0.01 microfarad. So the frequency, the general frequency is equal to 1 over 2 pi RC. After that is 1 over 2 bracket 2 and bracket pi and times 50 kilo and times with 0.01 micro. So the final answer is 1.06 kilohertz. So after that we move to the oscillator 2. Oscillator 2 is also type bridge oscillator. The general frequency is 20 kHz. DC supply of DC is also plus minus 50 volt. So this is the simulation that we get we use Sim. So that we get this result on oscilloscope. Move to the calculation for oscillator 2. So the given is the frequency is 50 kHz. DC supply plus minus 50 volt. So we assume that resistor is equal to 10 kilo ohm. Capacitor is 550 picofarad. With that, the general frequency is equal with 1 over 2 pi RC. So that 1 over 2 times 5 times 10 kilo and times 550 pico. So the resonance we get is 29 kilohertz. So the loop gain 1 plus RF over R3 equal to 3. RF over RT equal to 2. So the remaining frequency is equal to times R3. So assume R3 is equal 10 kilo ohm and F is 22 kilo ohm. So we just divide this 22 kilo divide by 10 kilo. So the final answer is we get 2. After that we move to the next part. Hakimi will explain.
Okay, thank you for my teammates, Muhammad Shaheel. So, my name is Muhammad Hakimi bin Halim from BEE section 1/1. So, today I will be explaining the rest of the circuit, which is active low pass filter, rectifier, and voltage regulator. So, for active low pass filter, we have second order low pass filter, and the cut-off frequency is 8 kHz. So for the circuit, this is the circuit that we have designed for the active low pass filter, and for the result that we get from the circuit, as shown in the picture below, in figure below. So for the calculation of the active low pass filter is first we use the for frequency cutoff, which is 8 kHz. So for formula, we use FC equal to 1 over 2 pi RC. So then we use the formula C equal to 1 over 2 pi RF. So our resistance, we use 1.8 kilo ohm, and frequency we use 8 kHz. Then we get 11.05 nanofarad. So moving on to the next circuit, we have a rectifier. So for the rectifier circuit, we use a full bridge rectifier, which then we will add the 1 microfarad at the output, and so that this is the circuit that we have designed for the rectifier, and the result in the oscilloscope that we get. So for rectifier, there is no calculation, and then I will explain straight for the voltage regulator. So for our voltage regulator, the output that has been given is 5 volt. So we use the type of OPM shunt regulator circuit. So we have designed the OPM shunt regulator circuit as shown in the figure. So the output that we get from the circuit is 5.143 volt. So for the calculation of the voltage regulator shunt is as follows, which is V out equal to Vz plus Vbe equal to Vin minus 1x Rs. So Vz plus Vbe, so as we know, Vbe is 0.7 volt. So Vz is equal to 4.232 plus 0.7 volt. So we will get 4.932 volt. So plus minus, we will get 5. So the output is 5 volt. So that's all from us for part simulation result and calculation. Moving on to the next team member to explain the next topic. Thank you.
Okay, thank you, AIMAN, for your full circuit explanation. Okay, now I proceed to the discussion. Me, myself, B08 1910 336 Nicholas Joseph from BEEE 1/1. Okay, in this experiment, we are required to equip few equipment and device to overcome the produce and output, which are the oscilloscope, rectifier, voltage regulator, and the active low pass filter. In the beginning, we have to construct the wind bridge oscillator. So we have to achieve the resonance frequency at 1 kHz by using the DC power supply, and VCC is 15 volt. The wind bridge oscillator is a feedback of circuit consisting of series circuit and connected with the parallel RC same component with value of producing phase delay of phase advance circuit depending upon the frequency. In this oscillator too, at low frequency, the reactance of the series capacitor is very high, so the act be like open circuit blocking an input signal with resulting a virtual of no output signal. So likewise, that the frequency of reacting the parallel circuit C1 becomes low, and then so the parallel connector capacitor act like bit like short circuit across the output. So there's no output gain signal. So furthermore, the resistor and the capacitor connected in circuit R2 and C2, while the others are parallel in R1 and C1, which are vice versa. So the indicates these two arms of the network behave identical of high pass filter and low pass filter. From the calculation value, the final answer resonance frequency cannot be same as the measurement value because its measurement is 20 kilohertz. For the final calculation value cannot get the same value. So we assume the value of R3 is 10 kiloohms. So the value of RF and are double, which is twice the times R3, because from the formula RF is divided by R3 and equals to the 2. So the value of we get from the both values 2. Furthermore, they are active low pass filter order butterworth response. The frequency cut off given is 8 kilo. We need to determine the value of resistor and capacitor value for the approximate butterworth response used in the circuit. The second order active low pass filter consists of 1 ohm and 2 poles with the first stage, 2 resistor and 2 capacitor. And non-inverting filter gain, as we can see in the oscilloscope, the voltage output is 1.5 volt and 8 kilohertz frequency of cutoff. Okay. The Y1 value, which gain in dB, is equals to 4.2501. For the next part, one of the low pass filter change in frequency of low frequency, and from the low pass filter will be changed to rectifier. So that will happen to rectifier and AC voltage. It will change the DC voltage and it will pass through the basic share regulator circuit. In the end, what will happen to the regulator circuit is the output will be produced from the whole circuit, which is 7.991 milliwatt. So for the next part, I proceed to the conclusion. As for the conclusion, the design circuit is complete with simulation using multisim by showing the output for each block. For example, output oscilloscope 1 and output oscilloscope 2, output of summer with calculated value. At last, understanding the calculation and the simulation of the circuit has been done, even though the problem on running the circuit with all the basic errors. We have managed to this experiment with our teammates without any misunderstanding between our group mates. Thank you very much.